Continuing on in section 12.6, with example 3 here, we're going to graph the function using a table of values, and then determine whether the functions have a maximum or minimum value. Again, looking here, because my x squared is negative, we know it's going to have a maximum value. It's a sad face parabola. So that's something to keep in mind as we go about graphing this. We're going to start off with a table of values. For my x values, I'm going to start off with -2, -1, 0, 1, and 2. And we substitute those into our x values in the x places. Remember, when there isn't a number in front of our x, it's a 1. So this is like -1 times x squared plus 2x minus 1. So keep that in mind when you're trying to find these values. Here I went ahead and plugged those in. Again, I just put my x values in my x spots, found my values, and those are the y values there. So go ahead and pause here and make sure you can type those in your calculator and get the values you need. Just a table of values like we did in the first half of the notes. Now, we can graph these points. So at -2, I'm at -9. -1, I'm at -4. 0, I'm at -1. 1, I'm at 0. And 2, I'm at -1. Okay. So here, we can start to connect. We can see we probably have a highest point, but I'm not 100% sure. We need 2 points on each side of the highest or lowest point just to make sure. So it looks like it's going to come back down on the right-hand side there, but let's do one more point just to double check. So if I plug in 3, again, I'm going to take -1 times my 3 squared. 3 is my x, plus 2 times that 3 value, minus 1, which gives me -4. So when I plot that point at 3, -4, we can see that yes, it is coming back down. So we need to keep going, guys, with points until we have at least 2 on each side of that minimum or maximum point, which we call our vertex. So here I have 3 points to the left, 2 to the right, and I'm going to go ahead and connect them. One other thing to note, guys, is from that maximum or minimum point, it's going to be symmetric. So I went over 1 to the left and to the right and down 1, over 2, down 4 in both directions on this one. So same heights, the same distance away, symmetric. Okay. So just something to let you know, hey, we've probably done this right. Now it wants to know whether we have a minimum or a maximum. Well, this point right here is our highest point. So we have a maximum, which we know because it was negative, so we were going to have a sad face parabola. The value there would be y equals 0. So the maximum value is y equals 0. And it happens at that point, which we call the vertex. Feel free to pause here and give this a try. Make a table of values for the given function. Then graph the function. Determine whether the function has a maximum or minimum value. So in example 4 here, we're going to make a table of values. So I'm going to make my xy table, and I'm going to input my x's. -2, -1, 0, 1, and 2. That's going to be where I start. Now I plug those into my equation. So I have 2 times x. That x is squared plus 5. And I'm going to do that for all of these x values. Now we calculate them. Remember, exponents come first. So if you're going to do this by hand, it's -2 squared, 4 times 2, 8, plus 5, 13. If you're going to do it in your calculator, we just type 2 times parenthesis -1 parenthesis squared plus 5. And here we'll get 7. Here we'll get 5. Here, 7 again. And here, 13. So now we can graph those. I'm going to go by a scale of 2's, so I'm just going to change my scale by 2 because I need to go all the way up to 13. And again, that changes it going down as well. We don't need any of the negatives, but it changes that entire axis. So at -2, I'm at 13. -1, I'm at 7. 0, I'm at 5. 1, I'm at 7. And 2, I'm at 13. So we can connect those. Remember, it's a U-shaped curve we called a parabola. Doesn't have to be perfect, guys. I want to make sure I can see where your points are and that you at least try to curve it, not a straight line. So that's our graph. Now we need to know whether it has a minimum or a maximum. Here we have a smallest point. It's a minimum. It doesn't have a maximum because if we look, the arrows keep going up. So it's going to keep getting bigger and bigger and bigger and bigger. Never going to have a biggest value, but it does have a smallest value there at 5. Here we'll do the same thing for number 5, so pause and give this a try if you'd like. We're going to make our table of values. I'm going to start off with -2, -1, 0, 1, and 2. And I plug those in to the x's in my equation. So here I'm going to have x, which is -2, squared minus 8 times x, which is -2, minus 2. I went ahead and filled the rest of them in. Now we can calculate them. Here I get 18. Here I get 7. Here I get -2. Here I'm going to get -9. Here I'm going to get -14. If we look here, guys, our numbers keep getting smaller. They haven't started to come back up yet. So we're going to have to find some more values. So I'm going to try 3. Plug that in for my x. We get -17. Still getting smaller. So I'm going to try 4. Here I get -18, so still getting smaller, but at least it's getting a lot closer. I went from 18 all the way down to 7 to -2. Those are some pretty big jumps, but here I went -14 to -17 to -18. A lot smaller jump, so it tells me that we're getting closer. So I'm going to try 5. Let me plug 5 in. And here I get -17 again. So we're finally starting to come back up. So I know I'm at least in the right direction. I need at least one more. I need 2 points on each side, at least of the lowest point, just to make sure that that is in fact our lowest point or our highest point. So I'm going to try 6 just to double check. And here I get -14. So I am on the right track. We have our lowest point. It's starting to come back up, so now we can graph. I'm going to go by 2's again here. And now we can graph our points. So at -2, I'm at 18. -1, I'm at 7. 0, I'm at -2. 1, I'm at -9. 2, I'm at -14. 3, I'm at -17. 4, I'm at -18. 5, I'm at -17 again. And 6, I'm at -14. So you can see it's starting to come back up. If we continued, we'd have points here, 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 and there. We can see because it reflects, it's symmetric, but we don't need those points. We just need at least 2 on each side to make sure that it's starting to come back up in the same path or to go back down in the same path, depending on. So here is the graph of our parabola. Okay, again, we need at least 2 points on each side of that lowest or highest point. Here, we have a lowest point, so we call it a minimum. And we can see that from our equation as well. It's a positive x squared, which means it's happy face parabola. And we have a lowest point. So there we had to find quite a few points in order to get this. It's not always that many. In the first one, for example, we just had to find 5. So it really just depends on what's happening in the middle of our equation there. Go ahead and pause here and give this one a try. We're going to go ahead and start off with our table of values. I'm going to insert -2, -1, 0, 1, and 2 to start with. And again, those x values go into the x spots in my equation. So here I'm going to have -2. It's still squared from my equation, plus 4 times my x value, which is -2. I went ahead and plugged those in just to save us some time. And now we can calculate. So here I'm going to get -4. Here I'm going to get -3. Here I'll get 0. Here I'm going to get 5. Here I will get 12. If we look here, our outputs keep getting bigger. I go from -4 to -3 to 0 to 5 to 12. They keep getting bigger, and they keep getting bigger by more. So we're not going to continue on in the positive direction here because those are going to get even further away. We're going to go in the negative direction. So the next one smaller is -3. I'm going to try -3. So I'm going to plug in -3 squared plus 4 times -3. And that's going to give me -3. So I'm going to plot my points right now just so we can see, since it's not in order, kind of where we're at. So at -2, -4, -1, -3, 0, 0, 1, 5, 2, 12 is all the way up here, and at -3, I'm at -3. So we can see it's starting to come back up in that way. And if we look at our graph, even if I wouldn't have plotted that last point, we can tell that it looks like it's getting closer as we go from right to left. So that's what we had to try -3 next. So let's try -4 just to double check. -4 squared plus 4 times -4, that x value. Here I'm going to get 0. 16 minus 16. So at -4, we are at 0. And if we look, it looks symmetric. We have 2 points on each side of our lowest or highest point. Here it's a lowest point. So we can go ahead and connect them. So again, it's a U-shaped curve called a parabola. We're going to try and hit our points. I missed there, so I'm going to try again. But it doesn't have to be perfect. See, I missed that too. That's okay. I'm on the right track. I can tell that I tried to make it curved, and I have points there to show me where it's supposed to go. So that's okay. Here, we look. We have a lowest point again. So we say this is a minimum. The minimum value is -4. It's where the y value is of that lowest point. So our minimum is -4 at our point called the vertex. And we see that because it's the lowest. Again, the arrows keep going up, so we're never going to have a single biggest point. It's going to keep getting bigger, but we'll never have a point smaller than -4, which means that's our minimum. And we can tell that from our equation, because again, it's positive, so we have a happy face parabola, which has a minimum value. So just a real quick double check there. And that's all I have for section 12.6.